Well, we finally get to do integration. Section 4.9, integration. Integration actually means to put things together, and to see why it's called that, we need to wait till the next chapter. But let me tell you another way to look at it. It is if y is equal to x cubed, then what's the derivative? You're right, 3x squared. That's taking the derivative. Integration goes the other way around. It says if y prime is equal to x to the 7th, then what was the original function? So in here, using the power rule, you bring the 3 down in front and multiply, subtract 1 from the exponent. Since we're doing the opposite of the derivative, we need to do the opposite of those operations. So instead of subtracting 1, we need to add 1. And instead of multiply, we need to divide. So the original function was x to the 8 over 8. The good thing about integration is you can always check your answer, because if you take the derivative of this, the 8 goes down in front, it will cancel that 8, you subtract 1 from the exponent, and you will get that y prime equals x to the 7th. Now, there's one other thing, because this could have had some constant sitting right here. So there might have been a 17 sitting right here. And when you take the derivative, this will still give you x to the 7th, and the derivative of 17 is 0. So this could be any constant. So we usually just call it c plus c. And that's called the constant of integration. So there's 3 main ideas in calculus: limits, derivatives, and integration. And integration is actually probably the most important out of the 3. I would list them as integration first, then derivatives, then limits. So you'll be doing a lot of integration for the rest of your calculus career. So I could write out the problem like this with all of these words and commas and this and all of that. There's another way to do it, and that is you use this symbol. So this is like a big curly S. So just take the letter S and then screen grab it and go like that to make it tall and skinny. So then you would put the function that you're talking about, x to the 7th right here, and then dx. And dx is telling you that x is the variable. So that's the symbol for integration. Or the integral symbol. So then let's do a few examples. So what's the antiderivative for x squared? So you can do the opposite of the power rule. So that means it's going to be x squared, and then you need to add 1 to the exponent, and then divide by that number, and then put a plus c. So in other words, the answer is x cubed over 3 plus a constant. And like I said, you can always check your answer, because if you take the derivative of this, the 3 goes in front, it's going to cancel that 3, subtract 1 from the exponent, you get x squared. And the derivative of a constant is 0, so that means that if you take its derivative, it's going to be x squared. Now, at this point in the semester, we basically have this rule, which is the opposite of the power rule, and then a lot of them can be done because you know derivatives so well. So in other words, like this one. So what function would go right here, so that when I take the derivative of it is e to the x. Good job, class. You're right, e to the x. And then don't forget the plus c. Number 3, what's the integral of 1 over x? So then search through your catalog, your memory of what function is it that when you take the derivative of it, the derivative is 1 over x. Good job, guys. Natural log of x. The derivative of natural log of x is 1 over x. Don't forget the plus c. Then moving on to example numbers 4, 5, and 6. How about some trig functions? So what's the integral of cosine? So what function is it that you take the derivative of it, and the derivative is cosine? That's right, it's sine of x. Don't forget the plus c. On tests and quizzes, I sell the plus c's for 1 point apiece. If you don't provide your own, I will provide it for you with a red pen, and it'll only cost 1 point. Next up, what about if you integrate sine of x? So at first I want to say cosine, which is close, except the derivative of cosine is actually negative sine. So what we're going to have to do is tack on a little negative right here. That way, when you take the derivative of cosine, it will be negative sine, and then it's negative and that negative cancel, and it gives you positive sine. Voila. Number 6. How about 1 over cosine squared? So that's one that y'all know. Maybe you don't know it in this form, but 1 over cosine is secant, so that means that 1 over cosine squared is secant squared. So what function is it you take the derivative of and its derivative is secant squared? You're right, tangent. The derivative of tangent is secant squared. So remember those 3x5 cards where you've got all those derivatives written down, and I insisted that you memorize a whole bunch of them? This is part of the reason, because it's very difficult to work backwards if you don't even know how to work forward. Next up, how about number 7? What's the integral of secant of x times tangent of x? So the answer would be secant of x, because the derivative of secant is secant times tangent. Don't forget the plus c. How about for number 8? So do you remember which inverse trig function you take the derivative of and it's 1 over 1 plus x squared? Excelente. Tangent inverse of x. Now, how about what's the integral of 100? So what do you take the derivative of? So the answer would just be 100. Well, that would be 100x. The derivative of 100x? Well, the derivative of x is 1, so the 100 will stay there. Derivative of 100x is 100. Don't forget the plus c. Let's see if I got enough room for another one. Then how about for number 10, the integral of x over x. No, that one's too hard. How about this? X plus 7 over x. Sorry, I was about to do one from the next chapter. I was getting too excited. So this one is a quotient, and there is a quotient rule for derivatives, but not for integrating. So instead what we need to do is use algebra. So rewrite this one as two fractions. Each of them have a denominator x, and then the top will be x plus 7. So you're basically taking one hard problem and breaking it into two easy problems. So first, this one could be simplified. That's just the number 1 plus 7 over x. And technically, this is supposed to be in parentheses saying all of its times dx. And then we're ready for the answer. So the antiderivative of a 1, that's just x. Because this one is like 1 over x, the answer will be the natural log of x, and the 7 will just sit there. And then, don't forget the plus c. Now, not each and every one of them have a plus c. So, for example, number 11, solve the differential equation so that just means an equation that has derivatives in it. And this one's going to be dy dt. So in other words, t is the variable instead of x. And then 1 over t squared plus t over 4 given that y of 2 is equal to 1. So we not only need to find the antiderivative, and then it'll have a plus c, then we'll plug in this for t and this for y, and then we'll be able to actually solve for the c, the plus c. Now, in order to find the antiderivative for this one, you could just look at that and go, oh, that's negative 1 over t, of course. If not, then what you need to do is rewrite this one as t to the negative 2, and this one could just stay t over 4. And before I go ahead and put the integral symbol, I should have all the t information on the right side and the y information on the left side. So now, multiply by dt, and the left side is going to say dy, the right side t to the negative 2 plus t over 4 dt, and then integrate both sides. So over here, this d is saying take the derivative. This is saying find the antiderivative. So these two are the opposite of each other, the derivative and the antiderivative. So they cancel each other out, and you just get y on the left side. On the right side, for this one, we'll need to add 1 to the exponent, which is going to be a negative 1, and then divide by that number. This one's exponent is a 1 right now, so add 1 to that, and then that's a 2, then divide by 2. So this one is going to be negative, and then it leaves t to negative 1, or in other words, negative 1 over t. This one is going to be t squared over 8 plus t squared over 8, and that for now there's a plus c. Then plug this in for t and this in for y. So plug in a 2 for t and a 1 for y, and then we'll be able to solve for c. So this is 4/8, so that means it's a half. That's negative half, so those two cancel out. So all that's left is that c is equal to a 1. For the final answer, just put that right here, and then we're done with that differential equation. So the answer is y equals negative 1 over t plus t squared over 8, and then replace the c with a plus 1. Now there's just 2 more examples that I want to do. And they go pretty fast, but they are important. So for example number 12, find the antiderivative for the third root of x plus 1. So to begin with, rewrite this one as x plus 1 is raised to the 1/3. And then add 1 to the exponent. And a 1 plus a third is 4/3, so then divide by 4/3. So when you divide by a fraction, that means invert and multiply. And then it's raised to the 4/3, throw on a plus c, and it's finished. And for the last one, lucky number 13, what's the antiderivative of e to the 7x? Well, since that's the e function, the derivative of the e function is the e function, and the integral of the e function is the e function. Yes, I know, plus c, plus c. But first, what about the chain rule? Because if you're taking the derivative, so if you think this is your answer and you take the derivative of the e function is the e function, that's true. But then you would have to take the derivative of this, which is a 7, and you'd have to multiply by 7. And this does not have a 7 right there. So what we need to do is divide by a 7 in our answer. That way when we go to check it, the derivative e function is e, and then we would do the chain rule and multiply by a 7, and then those two 7s would cancel out, and it gives us that. Okay, so that's such an important idea. We'll do one last one. Really guys, the last one. So for example number 14, how about if it was cosine of 14x? So the antiderivative of cosine, that is sine. Sine of 14x. The chain rule would say if you're taking the derivative, you multiply by 14. Because we're doing the opposite of derivative, you do the opposite and you divide by 14. And don't forget plus c. Okay, so that's our brief introduction to integration. We'll do lots of stuff with integration in the next 5 to 19 chapters.